There we go. So yeah, if you have a question, pop it in the chat. Meanwhile, let me know what's your exam board. What are you most worried about this year? Is there anything you would do differently compared to last year if you're just starting year 13? I will tell you a little bit about myself in case you don't already know. So, why am I here on YouTube on a Saturday morning? I've got about it is 20 years of experience now, in more than 20 years experience in teaching and tutoring chemistry. It's been 20 years since I qualified as a teacher, so I'm fully qualified. I've worked in schools abroad in Dubai and also in the UK, mostly in the UK. I've worked in sixth form colleges, normal sort of state secondary with sixth form, and also independent schools. So I've seen a really big range, everything from, sort of top selective entry schools to universities as well. I've worked with teachers um, and also, sort of what they used to call special measures schools. So I've kind of been in lots of different environments with lots of different students. And also that means that I've covered all the exam boards. So with OCR and EdXL and AQA, and I've examined for most of those as well and worked with them on some resources. So that's me. I live in the New Forest. I love going outside. I am also a Gold DofE instructor, not very relevant for today. And I don't teach in a school anymore due to some sort of chronic health conditions. I work completely online, and that's what I love doing, is spreading the chemistry joy. So had some questions about some of the things in the challenge. Give me a thumbs up if you have actually been doing every day of the challenge, or let's say 3 out of 5. Has anyone actually managed to do all of the different activities in the challenge? Then I would be impressed. Oh, well done. So, and that's impressive because it's pretty hard work trying to fit that in at the beginning of term. I know. Okay, so there were a few questions that I had sent in from about some of the quizzes and things like that. So I want to talk briefly about ionization energy and why students get this wrong, even if you've sort of learned it. And one of the main things that people get in multiple choice questions is making assumptions, and that happens a lot with written questions as well, is you assume something that's not there in the question. You do your practice questions, which is great, but then by not reading it correctly, or your brains are really good at just filling in stuff that isn't there, and that happens to everybody, not just chemistry students. It's a natural sort of problem with the human brain, right? We fill in stuff that's not true. And so with this question here, this throws a lot of people, like, which one of the elements on this graph is group 7? Some people will literally just go in and count and just be like, okay, well, that's 1, 2, 3, 4, 5, 6, 7. Then they get confused because they can't go to 7. There's no option. It's an ABCD question, and they start guessing. Um, or they decide that C is group 2 because they know that there's a drop between group 2 and group 3. Okay, and they're like, oh yeah, I remember that. So, that must be group 2. Either way, or sometimes they think that this is one element and that we're like taking electrons away. So what this is this is atomic number down here. So the only information that you've got is first ionization energy, atomic number, and a pattern. That's all you've been given. You don't know what period they're in. You don't know that they're all in the same period. All you know is that atomic number goes up at the bottom, um, and that they're sort of in order. So each element goes up by 1. So what you have to do is know where the biggest drop in ionization energy is. So if there's a really big drop like that, then that means that C is group 0 or group 8, and D is group 1. which means that B is the answer to the question because it's the one before group 8. So where we would go wrong is if we just assumed that it started from group 1. It doesn't say that. So if it says these are what I would call uh, the first ionization energies, they're consecutive elements. Okay, so the elements are going in order. I don't know why it doesn't let me do that in the corner. Consecutive, following, increasing atomic number, like they are different elements. People also make assumptions when they have ionization energies on the right-hand side. Anyone know what that graph tells me on the right-hand side? So this time, this is a single element, and this is what we might call successive ionization energies. So all of our ionization energies are like giving us some reasons, some explanations, observations that match electron structure. That's what ionization energies are for. That's why we learn about them, because they tell us about the structure of the atom. They tell us about shells and subshells and orbitals and where the electrons are. So if you've got successive ionization energies, what does that mean about that element on that graph? What can I know about it? Oh, okay, hang on, let me just let someone in. Okay. Yeah, so there is a big jump between the fourth and the fifth. And so all that tells me is that element is in group 4. So that where the assumptions part comes in is where people might look at it and go, oh, 7 electrons, nitrogen. I'll just have a look on a periodic table. No, sorry, A-level chemistry is not that easy. You might have noticed, you should have noticed by now. It's not going to be that simple. Again, that would be assuming that all of the electrons have been removed. Doesn't say that. Doesn't say that anywhere. If all the electrons were removed, there would be 2 at the end because there's always 2 in the first shell. So what this is showing is this is the outer shell. And this is some of the electrons in the next shell, but not all of them, because there's never a shell with 3 electrons in it. If it was, so what that tells me is it's group 4, it's not carbon, because it's got 7 electrons and carbon's only got 6. So I can already whittle it down to silicon or something underneath silicon. And if it was in the question, it would probably tell me what period it is. These are details that we have to look out for. So that's ionization energies. Okay. I also had some questions about sulfur, especially, and bonding, and weird, like, bonding that sulfur does, because sulfur comes up in loads of different, like, shapes of molecules questions. And what I'm talking about here is things like SO2 and SO3 and H2SO4. And when you do a shapes of molecule question, some of you will have been taught this method where you like add up the electrons in the outer shell and you just kind of like, I'm not even quite sure what it is, but you just kind of work out the number of lone pairs. Has someone been taught that method where you just kind of, it's this many and this is like 2 and this is 6 and I'm just going to work it out. And that works most of the time, but it does not work if you don't consider that some elements make double bonds. And that is where some people go wrong. They think there is a lot more electrons than there actually are spare. Because what they will just do, instead of drawing it out, they'll just go, oh, right, there you go, 2 bonds. So that means there's 2 lone pairs. Well, that does not work. Oxygen can't make a single bond and then just leave what its other electron just like hanging, not doing anything. Oxygen is in group 6. You can't have odd numbers. You can't only share 1 electron. So that means that that molecule would be like that. Now, if oxygen is in group 6 and it makes 2 bonds, we are done. Like, and oxygen does have lone pairs. I could draw them on. It's not important for the shape. but they are there. I've done too many, haven't I? Hang on. One, two, three, four. Oh no, I haven't. So one in each bond, and then four left over, group six. Sulfur is in group six. It's shared four. So just think of every line as sharing one electron. So it's got two left over. So there is a lone pair, but just one. And then the other thing that people do with the shape there is go, oh right, it's like water then. Okay, it's 104. No, it isn't, because it's not two lone pairs. It's three things. Double bond, lone pair. So what you need to do when you're trying to work out a shape is don't just go, oh, it's V-shaped, so it must be the same angle as water. You would go, all right, how many pairs of electrons does it have? Or like double bond is just one set because it can't move. So there are three areas of electrons, which means it would be 120 degrees, but it's not 120 because we've got one lone pair, so we just decrease it by 2.5-ish. There would be some leeway in the math scheme because you're only estimating. And then we would have this. Oh, that was a terrible drawing, but you get the idea. Nice little bent molecule. SO3 going to be completely different because I've got three oxygens. And so actually, every single one of my pairs of electrons in sulfur is being shared because there are six electrons and there are three double bonds. So there's no lone pairs, and that would be 120 degrees, completely trigonal planar. And then H2SO4, I'm going to put this one in. All I'm going to do with H2SO4 is show you how to draw it because it comes up, especially in AQA sometimes, and it comes up as one of those like challenging diagrams, but it isn't that challenging. And here's my trick for drawing H2SO4. If you can draw a carboxylic acid, I kind of hope by now that you can draw, like that's your carboxylic acid group. Okay, so C double bond O, OH. So put an S instead of the C. Draw it like it's a carboxylic acid and then draw exactly the same on the other side. And that is what, and if we want to do a displayed formula, then we should show all the bonds. So that is what the bonding looks like in H2SO4. And then if you had to draw a dot and cross diagram of that, you just replace every one of those lines with a dot and a cross, right? Because it's just a bond. So really easy when you look at it like that. Start to look at, and that's why they're both acids. They both lose the H from the OH. That's all it is. So what you'll notice is that sulfur is making a lot of bonds. Like in those two diagrams of SO3 and H2SO4, there are 12 electrons around the sulfur. That's okay because sulfur is in period 3 and it's got D subshell that it's not using. So it has space. So you can fit more than 8 electrons in the third shell, not in the second, but in the third you can. Okay. I also realised that I put a spot the errors thing in day 2, I think it was, on physical calculations on enthalpy changes, and I forgot to put the answers. So this was one of the errors. Did anybody spot two things that is wrong with this equation? I'll give you a moment. And I'll give you a clue. One of them is to do with the state symbols, and one of them is to do with the balancing. So there's a lot of like adding up now to see what the problem was. But yes, you can tell me in the private chat if you don't want to give spoilers to people. Okay, so I was going to do it in red and I thought that was a bit harsh. So I'll keep it to my nice blue colour. So, oh, I got an answer. Yeah, nice. So standard enthalpy of combustion needs to be per 1 mole. And if you've looked at my enthalpy change definitions video, it will really help you with that. So although the balancing is correct, okay, so if it just said write a balanced equation for the complete combustion of propan 1ol, this is correct because you can technically have really big numbers in front so long as they are the correct ratio. But if it's a standard enthalpy change, formation, combustion, neutralisation, etc., it's per 1 mole of whatever's happening. So 1 mole of compound. So that should be 1, that should be 4.5, that should be 3, and that should be 4. And it's fine to use 4.5 in front of something like O2 or Cl2 or H2. And then the other thing that's wrong, absolutely, is the fact that that is a liquid, not a gas. So I sometimes get students asking me, how do we know? How do we know when something's a solid, liquid, or gas, especially when you're doing enthalpy change of formation? Um, First of all, look in the question, often a clue. You know, if there's an experiment where they're measuring a spirit burner, it's a liquid. You can't put a gas in a spirit burner and measure it. So, so sometimes there's clues like that. All alcohols have hydrogen bonding. So if it's got hydrogen bonding, you know it's going to be a liquid. It doesn't matter how many carbons it has. If it doesn't have that, so if it's like an alkane or an alkene, then generally four up to 4 carbons is a gas. You know, so butane is a gas, propane is a gas, etc. And then after that, it becomes a liquid. Around about that time, they would probably tell you. And again, if it's an experiment where they're measuring it out and pouring it into something, then you know it's a liquid too. Ionic compounds, solids, metals, solids, obviously they have to be. That's their bonding. And then in most covalent substances, other than that, we're just going to assume that they're gases. Okay, there were some other errors here, so I'm actually just going to point them out um, because they're quite common ones. The first one, so this is a bond enthalpy. It's quite a lot of bonds to calculate. Is this whole 2 lots of CC bond. So here is C2H5OH. And bond enthalpy calculations should be easy marks. Okay, it's not that hard to add up the stuff on the left, add up the stuff on the right, and take it away. It's the ease. So calculations, lots of students get really hung up on difficult calculations. I've been examining a long time. You're not losing the marks in the difficult calculations, or certainly not the marks that are making the difference between the A and the B, or the A and the A star. Where you're losing the marks is again this assumption that it's easy and you're rushing it and you're not checking it. That is why I do these spot the errors exercises. Because all you needed to do was draw this molecule out, you know, and it's a GCSE level of question to draw out ethanol as a displayed formula and see that it only has one CC bond. And also see that it has an OH bond, which has not been added to the left-hand side. So, oh yes, yeah, so we've got the 3 times 496 is correct. 360, which is the CO, and the 5 times 412, which is correct. But they're missing this, and they've just added an extra CC. And the reason that we often miss the OH bond is because we often don't even draw it when we're drawing a displayed formula. And then on the other side, it's very typical, again, due to not thinking about the molecule being made of more than one set of bonds. They've done the 2 and the 3, but they haven't thought about the fact that each of those molecules has more than one bond. So it should be 4 lots of CO and 6 lots of OH. So that's really, really typical. And then the last typical error that's gone in here is they've got a big number and a small number. Possibly might have thought, okay, I know that the answer has to be negative, so I better just do the small number, take away the bigger number. But that's not the order that it's meant to be. It's meant to be bonds broken over minus bonds made. And if you link that to the enthalpy level diagrams that we know and love, you know that we go up before we come down. And this is my delta H. That's really badly. So this up arrow is the positive number of the bonds that I break. I have to do that first. And the arrow down is the negative number. That's why it's going downwards of the bonds that I make. And that's why that happens second. So if you get the wrong numbers, just do left minus right. Don't change the direction just because you're thinking, oh, it's meant to be a negative number. Another analogy of that is where you get the wrong number for a percentage yield and you're going to end up with more than 100%. If you don't have time to work out why you got it wrong, then at least do it the correct way round, even if you end up with more than 100%, because you're doing the right working, following on from the wrong number. So you can get really crazy answers and still get like 5 out of 6. If maybe you like, I don't know, divide it by 1,000 instead of timesing by 1,000 somewhere or something like that. But so long as all your other working is fine, then it's good. Another point on checking, and the only thing I want to say to that is that when I say check calculations, what I see students doing is not checking. What I see students doing is looking at it and going, yeah, looks right. That's not checking. Literally pick up your calculator and do it again. Like write it all out again if you have time. All right. If you don't have time, I would especially like go back to the ones that you did quickly that you thought were easy, because that's where you're losing it. Oh, good. A question on, yeah, I will do that. I'm just gonna do this one because I've got the slide up and then I will move on to yours on the temperature change during neutralisation. Um, Two reasons that it differs from the experimental value. So what this has done is they've just listed experimental reasons. That question that we just did was about bond enthalpies. It wasn't an experiment. We used bond enthalpies. Um, and so there are average bond enthalpy. That's one of the reasons, is that bond enthalpies are average values. So, the OH bond in an alcohol is not going to be exactly the same all the time. The CH bond won't be exactly the same. But a far bigger source of error that most people don't seem to realize is that bond enthalpies. Oh, that's not how you spell bond. Bond enthalpies are in gas state. All of them, everything, even water. And water is nowhere near a gas state at room temperature and pressure, which is what the standard conditions are for standard enthalpy change. So you can't usually actually get a good value of a standard enthalpy change from bond enthalpies. Sometimes in the question, that's why they'll actually show gas in the state symbols, because that's what you're really calculating. You're assuming everything's already in a gas state. Because otherwise, I can't measure the OH bond in liquid water. If I have liquid water and I heat it, I'm not breaking any bonds. I'm just breaking the hydrogen bonding, the intermolecular force. Okay. Question about the temperature change during neutralization. And I think that was the one where it was a multiple choice and it was mixing like double the volume of, or is it double the concentration? I think it's double the volume of acid and alkali. I think that was the one. So one thing that you've got to note about that is that when you mix the acid and alkali, they give off energy. Obviously, it's an exothermic reaction, neutralization. It gives off a certain number of joules per mole, and that's a standard thing. And then that goes into the surrounding solution, this heat energy, and raises the temperature. And the amount that it raises the temperature depends on, so if we look at our equation, Q equals mc delta T. So the change in temperature, delta T, is equal to the heat energy given off over the mass of solution times specific heat capacity. So I think this was the multiple choice that you're talking about, was where we doubled the volume of both the acid and the alkali. So what we did was increase Q, right? I get twice as much energy out. But what I also did was double M. If I have double volume, not double concentration, I have increased the moles, but I've also increased the amount of water that's in that beaker. So I may have given out twice as many kilojoules, but I'm using it to heat twice as much grams of water. Since most of that solution is water, right? Very little of it is actually acid or alkali. 99% of that solution is water molecules. That's what's being heated up. That's what's absorbing the heat. The specific heat capacity of water is like a fixed thing. So yeah, if you use double the energy, but you're heating double the solution, you will not have any effect on the temperature. It should be the same. Um, the only way that you can get a bigger temperature rise is by increasing the concentration of the solutions so you get more moles in the same volume, so you're not trying to heat more water while you're doing it. Does that help? Hopefully for that one. I think that was the one where people get caught out. And actually, related to that, there was also one about titrations in the experimental questions. Um, so, titration calculation. I've done a whole, there is on YouTube like an old class that I did, which was about calculations from experiment, and we did a little section in that about errors. And one thing that students do wrong a lot is often answer questions about errors in experiments, and they say, oh, it would change the value. It'll be wrong. It'll be different without saying which direction. Sometimes we can even make a prediction like it will be double or it'll be half, but usually we should definitely be specific and say whether something is higher or lower. And so what students will often do is go, well, I know a lot of these are mistakes and I shouldn't do them, but what I haven't really worked out is how does it affect the result? Not just make it different, but does it make it higher or does it make it lower? And to do that, you've just got to like take a little step back and look at what values you put into the experiment. So there is a flask. Some bad drawings coming up. Strap in. There is a graph. That is a conical flask. If you thought the conical flask was bad, uh, my screen's at a bit of an angle for various reasons, to do with my keyboard breaking this morning. So that means that there is a pipette. Oh no, that looks like a chicken baster. Let's not. There is a pipette there, a volumetric pipette. We take 25 centimeter cubed of acid. So I'll write that down, HCl. That's going in there. Pop a bit of indicator in, and then we are titrating it. And so one thing is I want to make sure I get the right way around, like which one's in which. Okay, so let's look at what will happen each time. The concentration of acid, how do I determine it? Well, I don't know it. So we assume that I know the concentration of Na2CO3 carbonate. I work out the moles of carbonate, and that's volume times concentration. And then I do the ratio, but that's 2 to 1. That's always going to be 2 to 1, so it doesn't matter. And then for the acid concentration, it's going to be the moles, essentially the moles of carbonate divided by 2 over the volume. And I'm going to assume the volume is 25 because that's what I picked up in my pipette. Okay, bubble of air trapped in pipette. Let's work it through. In the pipette, that means I didn't put 25 centimeter cubed of acid in the flask, but I did think that I did. Okay, because I didn't see the bubble. So I think I put 25 in. So what I've done there is put not enough moles of acid. It's the same as if I spilt a bit. Like I measured out 25 and then spilt a bit before it went in. So there are less moles of acid. That means my volume of carbonate will be less than it should be. which means my moles of carbonate will be less, which means I am going to think there's less moles of acid because I think there's 25 centimeter cubed in there, but there actually isn't. So actually, that is the only one that will give me a lower concentration of acid. Looking at the other three, bubble of air in a burette. When you open the tap, the bubble comes out and the liquid in the burette goes down. And you think you've added, say, half a centimeter cubed of alkali, but you haven't. You've just added air. So you're going to need to add more alkali, or it looks like you've added more alkali. So it looks like you needed more moles because some of what came out was actually air. And that means that you're going to have a higher concentration of acid that you calculate because it looks like you needed more moles of alkali to titrate it than you actually should have. So that one would make it bigger concentration. Rinsing the flask with distilled water does nothing. And the reason for that is because the amount of moles of acid is what determines the alkali. And it doesn't matter if I add acid to water. That's okay. I could put like a liter of water in that flask. Obviously, I probably can't because it's not big enough. But I could put loads of water in that flask. And it wouldn't make a difference. So long as it doesn't react with acid, I've put the same number of moles of acid in, and that depended on the pipette, not on the flask. I'm not measuring anything in the flask. So that will have no change. And in fact, that's what you're meant to do, is rinse the flask with water. Rinsing a burette with distilled water, no, that doesn't work because what you've done there is dilute your alkali because you are using the burette to measure something. So you can't have it full of loads of water because now, and it won't be loads of water, but it's enough to make your titration wrong because titrations are very accurate and you don't have to be wrong much to make them very wrong. Okay, any other questions on those? Experiment questions, that kind of thing. I want to actually move on to sort of less focus on chemistry specifics and more on revision for this year, strategies, other questions about. Nobody told me anything they're worried about, so I can only assume that nobody's worried about year 13 or A-level chemistry in general, and it's all good. I think that's probably a slight lie, but hey. Okay, so NMR, you're worried about NMR. Oh, I don't know. I quite like that actually. It's just a puzzle. It's fine. It's absolutely fine. But it is a good point. So, one questions is I get asked a lot, like, what's the difference? You're going from first year to second year of A level chemistry. So there are like, there's a lot of things that aren't different. But what I would say generally is, I'm really sorry if this is going to throw you, but there is more maths. Um, None of the maths is on its own hard maths. Okay, so none of it is, you know that already from a mole calculation on its own, moles equals mass over mr. That's not a hard thing to do. More the application just means that now that there are a lot more different calculations, it will be easier to mix them up if you don't practice them regularly. So I was working with a student recently who was retaking, and actually he already has got mixed up between the rates and the equilibria calculations because there's just a lot. Okay. And a lot of things that you talked about in words before, like equilibrium, like kinetics, rates of reaction, like redox, will now be described more in numbers. And there's a lot more enthalpy change stuff as well, which is why I put quite a big focus on physical chemistry and calculation stuff in the comeback challenge, just to hopefully get you back into that. So there's more maths, and of course there's also more organic. And what you will find is that the organic is more synoptic. And again, keeping on top of things is really important because previously you might have done your alkanes and alkenes, and then you did haloalkanes, then you did alcohols, and there's a limit. There's only 4 functional groups they could ask you about. but there's a whole load extra being added on, and they all link together. And as you move on and do more organic, you've got to stop thinking about things as I'm just doing this one organic topic now and think about all of organic chemistry. Probably later in the year, either February or Easter, I will run another like free organic workshop thing because I know that it's an area that students get overwhelmed, and we will definitely talk about analysis. And if you look at my old ones, we did some stuff last year specifically on analysis and NMR. So when you get to that, if you get worried, go ahead and watch that on YouTube because we did a lot of techniques that will hopefully make your NMR easier. And if you don't know what NMR is yet, don't worry, got time. Um, and then I would guess, unfortunately, um, just like with your GCSEs, in the second year of A levels, you're going to feel more pressure. And that's not only because it's obviously shorter, you're actually going to be you're going to be done with the course probably by April, um, or the end of April, and therefore you're cramming a lot more in. You probably already started the year 13 content last year in the summer. You may have forgotten stuff or missed it because you were on open days. And that is the other thing that I find is very disruptive this time of year is obviously your teachers are trying to like get you through the A levels, so they're plowing stuff on. But at the same time, you're like, I've got to do my personal statement, I've got to do my UCAS application. And there can be like, I feel like sometimes September like is a blank in students' minds because they're so focused on that they're not doing the stuff in the background. But cramming isn't going to work. So how do we take the pressure off? We take we need to start thinking about our future selves, which is very difficult for teenagers, I know, because it's not something that happens in their head. You've got to start thinking about doing things little and often and not trying to just, I don't know, do this one topic as it comes and just focus on this topic and then focus on the next topic. You've got to keep reminding yourself about the previous topics, which is why I did the comeback challenge to try and give people a stronger chance. Um, and so the question for that as well, I guess, is how to revise. Um, what should we be doing? And I think um, we're guilty of this as chemistry teachers. Like chemistry homeworks can either be super easy and short, or they can be horrendous. And there doesn't seem to be a lot in between. And we do tend to focus on, oh, here's what we did in the lesson. Let's practice what we did in the lesson. And if you only ever do that, if you only ever do the questions that your teacher gave you each time, unless your teacher gives you loads and loads of stuff and a really good schedule, then you probably are lacking in that remembering of the past topics. Um, and that's when you get the shocks. That's when I get students coming to me going, I was getting 80% in every test, and then I did my end of year exam or my mock exam, the end of year 12 or beginning of year 13, and I got 60%, and I don't know what happened. Um, and what happened was you thought you were okay because you were getting 80% in all the tests. But as it turned out, reactions of group 2 compounds aren't that interesting, and you don't actually remember them if you don't look at them for a couple of months. So, 3 parts to revision is there's the bit where you're, or just to understanding and getting that grade that you want. There's the learning and the understanding. There's the first time that you go through something, you've got to hopefully understand it. Now, actually, I'll put a little like you don't understand it first time every time. And I know that. Obviously, I'm a tutor. That's literally my job half the time is explaining things a second time to people that didn't get it the first time round. And I don't think that's a reflection on teaching. That's just not everyone gets it first time round. Um, I told one of the things I like doing in my spare time is dancing. And I've been doing it, a particular type of dancing for 10 years. Sometimes in a class, somebody thinks that I'm getting it really quickly. It's not. It's because like it's the fourth time I've done that particular concept, right? So repetition to that is part of the learning and understanding. When you do understand it, that doesn't mean it's in there, right? And if it's in there, that doesn't mean that you're able to bring it back out. So you have to do the retrieval practice. You have to just keep practicing getting it out of your head. That doesn't mean doing past papers. That means doing little practice questions, quizzes, multiple choice, although multiple choice is a bit exam technique, but short answers, learn a definition, write it down. Learn a mechanism, write it down without looking. It's as simple as getting a piece of paper out and saying, what do I know about haloalkanes? I'm going to write everything. Um, it's also things like the questions in the back of the textbook, like the chapter questions. If you've got a textbook or a revision guide, most of them have a small amount of questions. Or a lot of the revision guides come with practice workbooks. Okay. They're not exam practice questions. They are just answer these questions based on this topic. You can use physics and maths tutor. You can use Study Mind, you can use Save My Exams, and all of those will have topic-based questions, and I've got some available as well. But just be aware, if you use things like Physics and Maths Tutor, what you're actually doing is exam questions, because that's all they have, apart from the flashcards, which are good retrieval practice. If you just do exam questions before you've done the retrieval practice, you're kind of wasting the exam questions. So be really careful about that because exam practice should be a separate thing. Retrieval practice is just what's the definition for enthalpy change? What's the mechanism for electrophilic addition? What's the name of this functional group? What's the name of this organic molecule? It's just keep practicing the concepts on their own without, 5 pages of background. And exam practice, some exam practice questions are like that, right? Because some of them are just one markers, some of them are just name this organic or like give me the result of this test. But some of them are, but a lot of exam practice questions are really, really long and working through a question, being able to understand what it's about. So the fact that you can answer a question about alkenes, an exam question, when you have been given a set of questions that you know is about alkenes, is very different to when you do a question in an exam paper and you don't know what the question's about. You might not even realize it's about alkenes. You see the difference. Alkenes is probably not a good example because you usually do know, hopefully. But it could be anything. Like it could be about atomic structure and you don't realize that it's about atomic structure because you don't have that context of, oh, I'm doing this set of questions about atomic structure right now. So that's why exam practice is different. Exam practice is sitting down and doing like a whole hour or an hour and a half in time conditions properly. Do your retrieval practice all the time. If you're doing retrieval practice and you don't understand it, obviously you need to fix that. And that's the other beauty of retrieval practice is it doesn't work if you don't understand it, so you can go back and ask before you get to the exam practice. Um, and the other question I get is, what should I do with past papers? Should I be doing them now? Well, I think you can feel that I don't think you should be. But I also know that in schools they hand them out. So I would say right now, if you want to do exam practice, do AS level papers. There's loads of them. There's 2 a year. So you've got like 6, 7, 8, oh, like nearly 10 years worth. Like 2015, these came out. 2015, or maybe they were examined in 2017. So yeah, you got at least 7 years worth. Um, and specimen papers. Do those. Uh, like maybe one a week would be good, especially if you've got mocks or something else coming up, or if you're doing like a retest to try and get your UCAS prediction up or something like that. So AS level papers. Another question. That is a really, really good one about different exam boards. Is there a major difference between AQA and Edexcel? Not really. So definitely not for AS level. So the structure of the papers is different. the content will be different. So I definitely don't recommend, therefore, trying to do any A-level paper right now. But as you get closer, I don't recommend trying to do an Edexcel exam paper instead of an AQA. I definitely, though, right now would, yeah, you can do AS level papers for either. OCR is a bit different. So I would say, so my little family tree, AQA and Edexcel are quite similar. OCRA is kind of on its own and is not similar to particularly to OCRB. Please don't like try and do an OCRB exam paper and think that it's going to be like an OCRA because they have a really different way of arranging their topics. Um, some things are the same, but not that many. So I do recommend um, AS level papers, and yeah, I would say most of the content you can mix and match AQA and Edexcel. Especially if you do Edexcel and you can't find anything because there's not enough resources out there. Yes, you can use AQA. There's a few things that are in AQA and not Edexcel, and vice versa. So there's a few organic tests and things that are in Edexcel. Edexcel's got quite a bit more organic content than the other two. And that's about it, really. Uh, there's a bit of the main thing that AQA has got that others have not got is the time of flight mass spec. That's the only thing off the top of my head that I can think of that is unique to AQA. And so there, if you had a question about time of flight mass spec and you're doing Edexcel, you don't need to know about it. And therefore, if you're bright and you're aiming for the A star, by all means have a go at it because they usually just give you all the questions or give you all the equations. And so actually if you're just happy with putting numbers into a mathematical equation, you should be absolutely fine. Don't worry, Prayam, it's going to be recorded and I will send you the link. Okay. So yeah, OCRA, I'm afraid there's not many that are like that. However, I have used Edexcel questions for ACR, but I guess the problem is you need to know which ones are not relevant to your exam board. Last thing about using past papers and AS papers in general, you've got to use the mark schemes and you've got to be really hard on yourself. Not in a way that, please, you're just going to say, I'm going to give up because it's too hard. What I mean by being hard on yourself, I guess, is there's no value in you thinking you got that right and going, yeah, that's fine. That's about what I said. Because that's half of what's happening is most students are missing the marks because they think that's what they said. And then it turns out that's not what they wrote down at all. Because again, our brain fills in the missing bits, fills in the words, or assumes one word means the same as another. So be strict with the mark schemes. Check the box that says reject and allow, and don't. If it says allow, think, okay, why is that just allow or accept? Why isn't it the actual mark? Why is it just the one that got 3? Because next time it might not get 3. That's usually what happens. Okay. Um, I had one other question, which I'm not going to have time to go through, but what I am actually going to do is do a whole video on it because I think it's really important, which was something like, what do I do if I have a bad teacher? Um, and that is such an important question that I am going to make a whole video about it. And it's going to be aimed sort of at parents as well, uh, with some strategies. Um, And actually, I would also like to say that apart from a very small number of exceptions, I don't believe many teachers are intrinsically bad people. I think what you mean is if I have a bad relationship with my teacher, which is not the same thing, it could simply be that they maybe are ineffective for other reasons, and that could be something to do with the school or their home life, various different things, or you may just not sort of click as people, okay, have different values. So there are lots of reasons why we might have a bad relationship with a teacher. So I'm actually going to make a whole separate video on that. Practice materials for edXL, international A-level edXL. Rock on. There is almost no difference in the content. International A levels. So IA, if you look up IAL, it's on the Pearson edXL website, same as the normal edXL materials. You want practice papers. They do 6 exams 3 times a year. So they do January, October, and summer. And um, papers 1, 2, and 3 are your AS levels, and then papers 3, 4, and 1, 2, 3, 4, 5, and 6 are your second year available. It's pretty much organized the same way. So if you know right now at the end of year 12 can do papers 1, 2, and 3 with almost no differences in the content. Paper 3 is a practical paper, so it's really good for revising practical content. Yeah, so that's really helpful. They all have loads of multiple choice questions, which is really good practice. And yeah, it's almost identical specification. There's a little bit of organic. Organic is the main place where things vary, by the way, guys. So if you're thinking, where does, you know, what should I be looking out for if I do try a different exam board? Um, it's usually organic chemistry where the main differences lie, and it's usually the second year of organic chemistry. Okay, I said I'd tell you about some freebies and also resources that I have on the website. So um, hopefully you're already signed up to my email list anyway. Um, I've been spamming a bit recently because we had the challenge this week, but normally I just send one weekly email and we have a quiz, we have other resources, we have like videos that I'm going to do a lot more videos this year, hopefully as well. We've got a section on the website with free A-level resources as well. And then there are options to pay a little bit more, like £5 a month will get you a whole host of different materials, so topic checklists, practice questions. That is available for edXL as well, along with AQA and OCRA. The multiple choice quizzes, I need to add a lot more in, but I will be adding them. And that comes with lots of, like about 22 hours of recorded group lessons that you can watch on different topics. The silver membership is exactly the same, so you get all the online materials, but I've added something extra because this is something that I think really helps a lot of students without them having to do like a class or anything else, which is the assessment part, i.e., having a regular assessment to keep them on top of the material and having a revision program so that it's all happening throughout the year instead of all being crammed at the end. And basically, every 4 weeks on that membership or every month, you get a 45 minutes to 50-minute type exams questions in the style of your exam board, not past paper questions. So not things that you've seen on physics and maths tutor or whatever, and not obviously 2025 papers because I'm not leaking exam content, right? I write them myself. I write them in the style of your exam board. And that then you get that marked and you get a load of feedback. And you get advice on, a recorded feedback. So it's not just ticks and crosses and marks like you get when you get your exam paper back from the exam board and you have no idea why you got something wrong. It's proper me talking through it, explaining, and also giving you some ideas about where you can revise or what to do to improve it. Gold membership is available only for AQA and OCRA. I've got 3 spaces in each of my group classes. So that basically includes all the online stuff and the monthly assessment, but with weekly group classes. So I only have 6 students in each class. So they're both half full at the moment. They've got spaces, and they're on Wednesday evenings. And that's just to give you an idea of all the topics that are available on the masterclass. So that's like the £5 a month. You get access to all of those videos and the practice questions that go with them. You also get access to predicted paper walkthroughs. So they are old predicted papers. They're not this year's. I haven't written them yet. Give me a chance. It's September. But I do write predicted papers. as well. And you get practice booklets on calculations and extended response. And you also get a whole calculations course because calculations is something that's so important that that is a lot more broken down. So if you're one of those people that just said, I really want some more practice, I really can't remember anything about percentage yield, I haven't got time to ask my teacher because, we're moving on with all these other calculations, that is there. There's also, I know a lot of people don't like paying monthly for things, and it is a bit ridiculous these days, like monthly subscription to potatoes or whatever. So you can take advantage of me not exactly being disorganized. I had a lot of things that happened this summer, including like a lot of wasp stings and things and hospital visits I wasn't expecting. And also my website took a lot longer than the person said it was going to. So that means that I was meant to be taking all of these off the website and not having them on sale because this is summer sale prices. So if you did want to download things like practice booklet for calculations or practice booklet for extended response, they're all available like really cheap at the moment. So take advantage of me being disorganized if you want to get yourself some more practice questions. Take advantage of being here now because if you've made it to the end of this lesson, um, I'm just impressed really because I know lots of people they click on a freebie and they do nothing and they don't answer, they don't even open their emails, let alone turn up to a live Q&A session, let alone some of you working all the way through the practice materials. And I think that should be rewarded. Yes, bronze membership is available for edXL and silver as well. So you can also have the assessments because I taught edXL for 12 years. So I'm pretty good at writing questions for edXL as well. Um, the um, I'm happy to give anybody who's stayed to the end of this meeting a 3-month trial for the bronze membership if you don't have it already. You can actually get a 2-week trial anyway right now, but I'm just going to extend it for you to a whole month, which is really helpful if you've got like mocks coming up and you want to look at different ones. Perfect. So all you've got to do is just let me know in the chat. Email me to remind me. That's just to remind me so that I can check my emails and tick it off like as a task. If you're interested in group classes, so I am happy to offer a 10% discount on those. So they're usually 110 per month, so that will bring it down to 99 per month. And for that, you get 4 hours of tutoring plus the assessments and the feedback as well. So if you're interested in that, please let me know. I've got people's names actually. Nobody's called iPad 505 or whatever at the moment, which is what happens sometimes. So I can see who's in the meeting. So if you want to take advantage of that, just send me an email after this. Other than that, if there's any other questions, let me know right now and I will do my best. Oh, here we go. We have da 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 da. That's just a thank you. That's cool. Lovely jubbly. All right. Um, so yeah, you email me. Otherwise, seriously, like I'm not actually that disorganized. I'm just getting a lot of inquiries this time of year. So definitely email me if you would like the bronze membership, because it's very easy. Because if you're already on the comeback challenge, and you're already on the website, I can generally just add you straight away into that. And that's it. All right. Have a great weekend, everybody. And I hope to see you again soon sometime. And good luck with the start of your A levels or the continuation.